Hello and a warm welcome. My name is Mr. T, your host, and I'm delighted to be presenting to you another lesson on functions. This is video number 2, focusing on two specific functions, that is your hyperbola and your exponential graph. Just looking at the theory of those two functions. So to start with, we're going to look at the general equation of a hyperbola, which is given by f of x is equals to a over x plus q. Just like all the other functions, we need you to realize and identify what variables make up that function. In this context, we've got two variables. The two variables are your a and your q. You need to know the effects of those two. So if you start off by a scenario where your a value is greater than 0, your a is positive, we expect our curves to be in quadrants 1 and quadrant 3 respectively, as you're seeing on the screen, quadrant 1 and 3 respectively. And if your a value is negative, we expect our graph to have its curves in quadrant 2 and 4 respectively. That's your quadrant 2 and quadrant 4 respectively. An important feature that make up a hyperbola is that it has two asymptotes, one of which is a horizontal asymptote, a vertical asymptote, which is given by x is equals to 0. The other asymptote is a horizontal asymptote given by y is equals to 0. Just to explain a bit further, where is the x is equals to 0 coming from? It's coming from that part of our equation. Anything in the denominator, if it's equated to 0, it leads to that x is equals to 0. Then finally, our q value is coming from that q value that you're seeing over there from the general equation. So those are our two asymptotes. We move on to an example just to contextualize it. If you're given an equation like f of x is equals to 2 over x minus 3, an important point to note there, just by looking at it, is that your a value there, which is your 2, is positive. And according to our theory, we expect that to be in quadrant 1 and quadrant 3 respectively, as you shall see. So let's quickly sketch that. You've got an option of using whatever method you're most comfortable with, either the geo-intercept method or the table method or the calculator. It's your choice. But I must immediately warn you, if you're going to use a calculator, that a calculator has limitations at times. So please do not over-rely on the calculator when it comes to coming up with values that you need to draw on the graph. So I will use the geo-intercept method. Obviously, without explaining it, you would have done it already. So the graph that we're going to have looks like that. Important. You have to start with your asymptotes when drawing or sketching any graph involving a hyperbola. The first asymptote there is your y is equals to negative 3. Where is that coming from? The y is equals to negative 3, and it's represented by a broken line, please, if it's an asymptote. It's coming from that equation, the q value. Then the vertical asymptote, which I'm showing you with a red broken line, is given by x is equals to 0. Where is the x is equals to 0 coming from? The x is equals to 0 is coming from, again, just a reminder, it's coming from equating whatever you have in that denominator to 0, which is equivalent to that. We move along and just say, look at the curves. You've got your curves in quadrant 1 and quadrant 3. And that again is with respect to your asymptote. So that curve that you're seeing is in quadrant 1, and that becomes your quadrant 3. Again, with respect to your asymptote. I'll say it for emphasis sake because it's important for you to remember that. Then the domain, which assumes your x values. In this case, it's going to be x an element of R, but x should never be equal to 0. Why should it be equal to 0? Because at x is equal to 0, it's an undefined region. with respect to that graph. No values can lie on that point, x is equal to 0. The range is y an element of R, but your y cannot be equal to -3. Again, same explanation. Your y is equal to -3 is an undefined region. We move on to an exponential graph. With our exponential graph, we're going to kickstart by stating the general equation, which is given by f of x is equals to a times b to the power x plus q. There are three variables there. Your variable a, b, and q. We need to investigate the effect of a change of each of those variables and how it affects the graph overall. We start off with the horizontal asymptote. Our horizontal asymptote is given by y is equals to q. An exponential graph, by the way, has got one asymptote, whereas a hyperbola has two asymptotes. But in both graphs, your y is equals to q, which is your horizontal asymptote, is explained the same. Your a value determines the shape of the graph. We're going to investigate that further as we look at examples in preceding videos. We're going to look at Q now, obviously just to give you an overall shape, an overall overview, just a graph alongside. This is a graph that we've just drawn. It's an increasing function, it's an exponential in nature, with an asymptote y is equals to Q. But let's look at our Q value. If our Q value is greater than 0, in other words, it's positive, it means that our exponential graph has shifted or must shift by q units upwards. The opposite is true. If our q value is less than 0, in other words negative, that means the graph must shift down by q units. We move on to the concept of domain and range on the next page, where our domain for any exponential graph is given by x an element of R, as long as the values are not stated, as long as the domain was not given originally. Our range, you've got to be careful with the range. I'm going to start off by saying the range will be y is greater than q, Remembering that the q value is your asymptote. That q value is your asymptote. So it's either your value or your range will be y greater than 0, and that is only true if you have a sketch like the one that you're seeing on the far right. Those are the two possibilities that will lead to a range which is greater than q. In other words, for both graphs, the red graph, exponential graph, and the yellow exponential graph, if you're having an asymptote which is below the two graphs, then your range has to be y greater than q. I hope you understand that. And also, if your y is less than q, your y is less than q, that is only true. Your range can only be y less than q if and only if you've got the following condition. I'm going to draw the graphs alongside as well. That is the scenario. If your asymptote is above your two curves, that's the only time where your range of values will be y less than q. I hope you enjoyed that lesson. Until next time, signing out is Mr. T. Bye-bye.